Welcome back. So we're on 6.1, switching between forms. So this is really a review. We've talked about how to switch forms before. So we're just going to go over that really quick. And we'll talk a little bit about graphing calculators. So it's kind of hard for me to do it right now using a graphing calculator with what I have, but I'm going to try and get a program so that I can show a TI-83 or 84 on here that we can kind of show how to work the calculator, okay, for graphing. But from now, we'll just go do this from hand. From this whole unit, you are able to do it without using a graphing calculator, but for sure it would take you longer. So let's just learn how to do it using the calculator so you don't have to spend so much time doing homework. All right, so like I said, we've talked about this before, the three different forms and how to switch between those forms. So standard form is y equals ax squared plus bx plus c. Intercept form is y equals a times x minus p times x minus q. And vertex form is y equals a times parenthesis x minus h close parenthesis squared plus k. So those are the three forms, and if you haven't memorized these, it's about time. So get working on that and make sure you know how to write those down. Okay, and then how to switch forms. So let's start at the standard form. If we have standard form and we want to go to intercept form, what we do is factor. Okay, so that's where we did the glasses and did this kind of thing and find two things that add up to give bx and multiply the first two terms that go in here. So if that reminds you how to do that. You can also look at your notes from Unit 5. Okay, so we factor to get to intercept form. And then to get it from intercept form to standard form is distribute. Okay, so to distribute, we FOIL, or you could use a box method, and those are ways that we can distribute. Okay, then if we have standard form and we want to go to vertex form, we can complete the square. Okay, so that's one way that you can do it. There's another way that you can switch it from standard form to vertex form, is to calculate oops, did that wrong. Calculate the vertex. Okay, so obviously the vertex form uses the vertex, and so if you can find the vertex, then you don't need to complete the square. So how we can do this, the vertex is the same thing as h comma k, and to find h and k, h is the axis of symmetry. Okay, axis of symmetry, oftentimes we write it as x equals negative b over 2a, and if we plug that in, we plug that in for our h, or we could plug it into here. That gives us our h value for our vertex form. Okay, and then to find the other part of the vertex, the k, well, whenever we have an x, we can always find its accompanying y by plugging that into your original equation. So if you take that, this very important equation, and we plug that into our original equation for our x's, that would give us our y value. Or you could say it's our k value. I know there's lots of arrows here. I don't know if this makes any sense. But if you can come up with the vertex by first doing the axis of symmetry and then plugging the axis of symmetry number into your original equation, that gives us our vertex, our h and k, and then from there we plug that in to our vertex form. Okay, so either way, you may need to go back and listen to that again. I know it's a little confusing, but those are two valid ways to come up with the vertex and get the vertex form. Okay, if you have it in vertex form and you need to get it into standard form, we just distribute. Okay, like I said, you can foil or box. Okay, and that's a quick review of what we covered in Unit 5. So let's do some examples. Okay, so given the following equation, identify what form it is. So looking at A, what form is A? Well, we kind of look at here, it looks like it is intercept form. Okay, and then we need to find the other two forms. So on the homework, there's going to be problems that ask you specifically for one, going from a given equation and put it into a specific form. So you won't have to do it like this where you need to write it as all three forms. So just read the instructions on the homework. All right, so here we have it in intercept form, and now if we follow the flow chart, if you have it in intercept form, you're going to follow the arrow, and now we can go to standard form. And to get standard form, we distribute. So, now right here, standard form. Okay, to distribute, there's different ways or different orders that you can do. You could distribute that negative to those two terms and then foil, or you could foil first, like these. And then after you have that done, then you can distribute the negative. So you can do it whichever way you'd like. I think I'm going to do the foiling first. So the F for the foil is the first two terms, gives us x squared. And then O for foil is the outside terms. That gives us plus 1x. I is the inside terms, gives us a negative 3x. And then L for foil is our last two terms, which is negative 3. Combine like terms, x squared minus 2x minus 3. And then distribute that negative to all three terms. That gives us y equals negative x squared plus 2x plus 3. Okay, so there we have it in standard form. I'm not going to do this on here. You're welcome to do it. You'll run into an issue. If this is positive, then you can get it in intercept form, but you can't do it in vertex. Okay, or at least you can't do it easily, and I don't want you guys to have to spend too much time doing that. So I did not do that in class. So I'm just going to do vertex here. This is all part of this problem for A. Okay, vertex form. All right, so you can use either of these two choices, completing the square, or you can just calculate the vertex. So I am going to calculate the vertex. So to get the vertex, we want to use our axis of symmetry, which is x equals negative b over 2a. B is, so we need to look over here, b is 2. So negative 2 over 2 times, and then our a is the coefficient in front of the x squared, which is just a negative 1. So that gives us an answer of 1. Okay, and now we need to find the second part for our vertex. Oops, my bad. Go back, please. There we go. Sorry about that. So to find the y value for our vertex, we plug it into our original equation. So you can write it as y, or if you want to try and, I mean, this y and x is the same thing as the h and k that goes in the vertex. So either way is fine. To write it as a y or write it as a k, they're the same. So we plug that into our original equation. You could plug that x into this equation in standard form, or you could plug it into in intercept form. Either way, doesn't matter. So I'm going to do it in intercept form. For me, I like that. So we plug in the y, or the 1, in for our x. That gives us 1 minus 3. And then our other x, we plug that in for 1 plus 1. Okay, simplify. That gives us negative 2 times 2. It gives us a positive 4. Okay, so now we have our vertex. Vertex is 1, 4. All right. So all we need to do is plug it into our equation. So it's y equals, we look over at our vertex form at the top left. It says y equals a. Well, what is a? A, we can find that from either our intercept form or our standard form. For intercept form, it's the number in front of the parentheses. And for standard form, it's the a, which here is negative 1. So we'll just put a negative. We'll write down our equation as it's written for our vertex form, x minus h. So here we look at our h, which is the same thing as the x value in our vertex, is 1. And then for our k, it's our y value for our vertex. So plus 4. And we have our equation in vertex form. Okay. If you like doing it by completing the square, that is just fine. Perhaps I'll write it just for those who prefer that. So completing the square, what we're going to do, and this is a little tricky sometimes when we have this a as a negative, because usually we don't have a negative for our completing the square. But we can still do it. So completing the square, what we do is we replace y is equal to 0. Y equals negative x squared plus 2x plus 3. Okay, and so the thing is that if you have a leading negative, you need to factor it out, just like when we're doing factoring, or yeah, factoring, yes. So we'll take that out. You could even divide both sides by a negative 1 if you'd like, and that ends up giving you 0 equals x squared minus 2x minus 3. And then we want to, we need to subtract, or add 3 to both sides. So that gives us 3. We'll leave a spot because we're going to need something there. X squared minus 2x, and then I'll leave a spot. Okay, and then to complete the square, we use our equation c equals b over 2 squared. And b is negative 2. So negative 2 divided by 2 is negative 1, and negative 1 squared equals 1. So we add 1 to both sides. Okay, and then we can write, simplify, that gives us 4 equals, and then now that it's a perfect square, we can write it as a binomial squared. So it's always going to be x, and then what we put in this else in this parenthesis is going to be b divided by 2. So b divided by 2 is negative 2 divided by 2 is negative 1. Okay, and then we want to put the 4 back to the other side, put our y back in there. So minus 4, y equals x minus 1 squared minus 4. But the one thing that we're missing is when we factored out that negative 1, we need to put in what our a is. So our a, which is the same for intercept form, standard form, is negative 1. So we'd need to put that in to have the right answer. Okay? And and you know, and this is one of the reasons why we don't usually have this leading negative for completing the square, is that it needs to go to, I mean, we put this negative 1 back in there, it needs to be distributed to both terms. So that gives us y equals negative x minus 1 squared plus 4. That makes sense, okay? So maybe I shouldn't have said the whole thing about the a value. It's just we're putting this negative that we deleted or we divided out. Now we need to put it back in, okay? And since we divided the whole thing by a negative 1, we need to multiply the whole thing by a negative 1. So like I said, that's why I kind of prefer to just come up with the axis of symmetry and come up with it that way. All right, so let's go and do C. We also didn't do D in class, but B we don't really need to use. But if you want to do number 2, A, B, and C, you don't need to solve those, but you'll need to plug them into your calculator. All right, for C, what form is that already in? Well, it's already in vertex form. Okay, and we will want to have it in standard form. So let's do that first. Because if we follow the flow chart, that's what we need to do next. So to get to standard form, our vertex form to standard form, we need to distribute. Okay, so first thing you have to do is you have to do an order of operations. So here, the first thing that's most important is the exponent. Okay, so to distribute an exponent, remember that anything that's underneath an exponent, you're multiplying itself. So we're multiplying x minus 1 by itself 2 times. Okay, if it was a cube, then we'd be multiplying itself by 3 times. Okay, so here we're going to rewrite this as y equals 3 times x minus 1 times x minus 1 minus 3. And then we can FOIL, or if you prefer, you can distribute that first. I like to FOIL first. So y equals 3 times, here we got x times x, that gives us x squared. X times negative 1 gives us a negative x. We have negative 1 times x, that gives us a negative x. And negative 1 times negative 1 is a positive 1, minus 3. Okay, and then what we're going to do is combine like terms. Okay, and then we want to distribute that 3 to all 3 terms. And like I said, you can do things in different orders and it will still work out. Like I said, if you wanted to distribute that 3 first, that would be just fine. So y equals 3x squared minus 6x plus 3 minus 3. And plus 3 and minus 3, those cancel, and we end up getting that for our standard form. All right. Next we have intercept form. And to get it from standard form to intercept form is factor. Okay. So if you recall, the first thing what you should always do before you start doing glasses or anything is you need to see if there's a greatest common factor. Because here, there is a greatest common factor, and that would be 3x. So if you take out a 3x, you're left with x minus 2. Okay, and that is fully factored. If you recall, we kind of talked about this before, that this could also be written as 3 times x minus 0 times x minus 2. So if you were to do glasses, I mean, you can from this equation, you could do glasses. You'd still need to take out the greatest common factor. Like, for example, if you, for some reason, you decided, oh, I'm going to take out the greatest common factor, which is x squared minus 2x, then you could do glasses and come up with the answer. Or you couldn't, even if you didn't factor out that 3, you could still do glasses, but since A here is not 1, you would have to do it the long way by doing grouping. Okay? So there's our 2 extra answers. If you have any questions, you can go back or stop by during office hours. And then here are some other examples. Trying to recall some of these answers on the homework. Maybe we should do one of these. Let's do E. Some of the problems in the homework are not like whole numbers. Some of them are rational, meaning that it can be written as a fraction, or decimals, if you prefer decimals. I'm not picky about whether you're having decimals or fractions in this unit, okay? So let's do E. What form this is in? That wasn't very good grammar. This is in intercept. So for an intercept, what we're going to do next is we're going to distribute to get standard. Okay, and then after that we will go to get vertex. But let's just start with this. We want to distribute. So we can keep that 2 out there in the front, and then we are going to FOIL. So that gives us x squared. X times 2 is positive 2x, negative 3 times x is in minus 3x, and then negative 3 times 2 is negative 6. Okay, and then combine like terms. Y equals 2 times x squared minus x minus 6. Okay, and then we just need to distribute that 2 to all 3 terms. So that gives us y equals 2x squared minus 2x minus 12. Okay, so that looks nice. No decimals, no fractions. But when we go and do completing the square, it won't turn out as nice. Okay, so like I said, I would suggest, rather than completing the square, using the axis of symmetry to find the vertex, and that would give us vertex form. Okay, so let's do that. Axis of symmetry is, I mean, you could, is x equals negative b over 2a. b is negative 2, so that'd be a negative negative 2 all over 2 times a, which is 2. And that gives us that gives us 2 over 4 equals 1/2. Okay, so I'm just trying to make sure I'm not missing anything. Okay, now that we have our x value, we need to find our y value for our vertex. This is all for the vertex. So we'll just plug that 1/2 into our equation. It can go to either one, our original equation that's in intercept form, or we can use the one that we calculated in standard form. So I'm just going to do it in standard form. So 2 times 1/2 squared minus 2 times 1/2 minus 12. Okay. And then you probably just want to do it on your calculator, or you can come up with it without using your calculator. And that gives us 1/4 minus 1 minus 12. That gives us 1/2 minus 13. That gives us a negative 12.5. Like I said, it's not a whole number, but it's okay. So all we need to do is plug it into our vertex form. So vertex form is y equals ax minus h squared minus k, plus k, sorry, where this is our k value and that is our h value. So y equals a. So what is our a? We'd have to look at our original equation or our standard form. So these are our a values. Okay, so we just take that and we just say it's 2. And then we have x minus h, and h we said is our axis of symmetry, which is 1/2 squared. And then we have our k value, which is the y value for our vertex, minus 12.5. So that is our equation in vertex form. Okay, so being able to do those 3 problems, you should be able to do most of your homework. There's 3 on the homework that you should just skip. It is 10, 11, and 12. Okay, you would run into where did I put it? Oh yeah, we have to have it in intercept form, which you need to factor, and you can't nicely factor it. So just skip those 3, and you'll be good. Okay. Number 4, they ask you to write the 3 equations you wrote in 1.A. So these 3 equations, and when you plug those into your calculator, and we'll talk more about how to do that. We didn't do that in class, but if you plug those in, they turn out to be exactly the same. So basically what we're trying to say is that the 3 equations are equal, but they're written in different forms. So they're exactly the same. They've been changed a little bit. Okay. B, it says enter both 1C and 1D into your calculator. How does the shape of the parabola in 1C differ from 1D? So you should be able to figure this out without even graphing. So if we look at 1C and 1D, they are exactly the same equations except for what? If you compare them, the only difference is our A value. Okay, so how do they differ when you graph them? 1c is going to be stretched because a is greater than 1. All right, and they'll both be concave up, and everything will be the same. It's just the a value, okay? Or you could say the growth pattern is different, but that's the same thing. Okay, and then finally C, enter both 1E and 1F. And how do they differ? This is a little more complicated if you look at E and F. Again, the only difference is our A value. Here A equals -1, and for E, A equals 2. So the difference is, well, what can we find from those A values? Well, if A is negative, then it's concave down. So we'll just write this down. For 1E, A equals 2, so it's concave up, and it's stretched. That's not supposed to be there, stretched. Whereas 1F, A equals -1, therefore it's concave down, and it's not stretched. Okay, so that's pretty much everything that we covered. It's pretty much just a review. If you have any questions, let me know during office hours, and we'll get all caught up.